Why is it so cold in space, while the temperature of some space objects, such as stars, can exceed tens of millions of degrees? Today we are going to answer this interesting question. Enjoy the show, my friends. Perhaps it is worth starting with the hottest of the currently discovered stars called WR102. WR102 is a Wolf-Rayet oxygen star. It is located at a distance of 9,800 light-years from the Sun in the constellation Sagittarius. WR102 is an oxygen star and is a representative of an extremely rare spectral class of stars. It has high luminosity and extremely high temperature, which reaches 210,000 degrees C, and this is only on the surface. What temperature is raging in its interior near the core is anyone's guess, but this value contains a considerable number of zeros. Let's move on to our star. The Sun, the closest star to us is a yellow dwarf star. The Sun is not a hot star compared to other giants in space. But despite its relatively small size, the Sun is very hot. The temperature of its core reaches 15.7 million degrees Celsius, and the surface, in turn, is heated to 5,500 degrees, which is quite a lot. Now let's look at the planet Mercury, the closest to our star. It's very close to the Sun. To the Sun at a distance of only 58 million kilometers. But at the same time, the temperature of its surface illuminated by the Sun is only 350 degrees C, which is also not insignificant. But as we remember, the surface temperature of the Sun is 5,500 degrees C, and the planet closest to it seems to be not so hot after all. And even so, on the other side, Mercury, which remains in the shade, the temperature generally drops to 170 degrees. And moving further and further away from Mercury's orbit, we begin to notice that the temperature of the surrounding space begins to drop faster and faster. Earth is our home and the third most distant planet from the Sun. The average global temperature on our planet is already only about 15 degrees Fahrenheit, with a plus indicator, of course. But at the same time, the Earth still has a mild and pleasant enough climate to support life. This is because heat is spread through our blue planet's dense gas atmosphere in three ways: conduction, convection, and radiation. When the Sun's rays heat molecules in our atmosphere, they transfer this extra energy to neighboring molecules. This transfer of heat from molecule to molecule is called conduction, and it is a chain reaction in which even nighttime temperatures still remain relatively warm, even as the seasons change. If we continue to move away from the Sun even further, for example, to the orbit of Neptune, and measure the temperature of its upper atmosphere, we see that the temperature is already 220 degrees Celsius. What is the reason for such a weak thermal influence of our star on the surrounding even near-field space? And why is it that outer space, in contrast to the same planets, is still so cold? To answer this question, friends, we need to understand what heat is in the general sense. Temperature is the kinetic energy of particles, molecules, and atoms. Roughly speaking, the hotter a substance is, the faster its atoms move or oscillate, and the colder it is, the slower the motion. If the chaotic movement of atoms stops, they form an ordered structure, occupying a precise position in the nodes of the crystal lattice. This is called absolute zero, which is 0 degrees Kelvin or 273.15 degrees Celsius. When the temperature approaches this mark, quite unusual phenomena begin to occur. For example, according to a study published in 2017 in the journal Nature Physics, in such conditions, light becomes a liquid that can be poured into a container. At NASA's Cold Spring Harbor Laboratory, researchers have even witnessed the existence of atoms in two places at the same time. Outer space is a vacuum. The space vacuum is not completely empty, of course. Because even in interstellar space, there are 5 to 10 hydrogen atoms per cubic centimeter. Nevertheless, the gas molecules in deep space are too sparse and far apart to regularly collide and transfer energy. Thus, even when the sun heats them up with its infrared radiation, heat transfer by conduction is not possible. But let's go even further. The more we move away from the sun, the lower the temperature in space will get colder and colder. Pluto's surface temperature will already reach a mere 240 degrees, which is only 33 degrees above absolute zero. If we continue on and reach the interstellar space, you can feel the true temperature of space. So how cold is it in space? Open comic space has a temperature of 2.7 degrees Kelvin, which is about 270.45 degrees Celsius. And that's incredibly cold. But let's finally find out about the coldest place in the universe that has been discovered so far. At a distance of 5,000 light-years from the Sun is a protoplanetary nebula called Boomerang. It, due to the high speed of ejection of gas molecules, was able to gradually cool down to a record minus 272 degrees C, or 1 Kelvin, making it the coldest known place in the universe. Thank you all for watching, dear friends. Please leave comments and subscribe to the channel. Your thumbs up will help promote the channel and motivate us to create new, interesting videos.